Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the June 2019 Algebra 2 New York Regents exam. As with other presentations, this is a thorough consideration of the steps to solving the problems. If you need a much quicker coverage, feel free to visit our website in the link in the description below, and then you can gain access to the transcripts of this video presentation and go through the problems at your own pace. Don't forget to subscribe to this channel so you can get updates to the remainder of this review series. Let's take a look at question number 11. On question 11, we're going to be assessed on how to factor higher degree polynomials. Question 11 reads the completely factored form of n to the fourth minus n squared plus 4n to the third minus 36n minus 12n squared plus 108 is, so we have the four options over here. Alright, so let's go ahead and factor this quartic with 6 terms completely and see which one matches. Okay, so we have n to the fourth power. Let's put it right here. N to the fourth power minus 9n squared plus 4n to the third. Now what we're going to do is we're going to factor by grouping, okay? So when you're factoring by grouping, what you want to do is you want to group the terms in a polynomial in such a way that you have identical number of terms in each group. So we have two configurations of grouping here. Since there are 6 terms, we can either group them with 2 groups with 3 terms in it. So we can do it this way. Have the first 3 terms, and then we can group the last 3 terms together. Alright, if we do that, of course, we're going to switch the signs. Alright, so that's one possible configuration. The second possible configuration is to group them where you have 3 groups with 2 terms in each group. Okay, so sometimes if you do it doesn't really matter whichever way you do it. In certain cases it does matter. In this particular case, if you group them in the configuration I showed you just now, it'll complicate the process a little bit more. But if we group them using 3 groups with 2 terms in it, that will yield the desired result. Alright, so what we're going to do is as follows. We're going to group the first 2 together. So we're going to have, let's write it this way. We're going to group together n to the fourth and minus 9n squared. So that's the first group. And then the second group are these 2 terms. And then the last 2 terms we're going to group together. Okay, so this is a little bit technical here because you have a minus in front. So if we group these together, it is as though we're factoring out a negative sign. So what happens when you factor out a negative? The signs of every term in that quantity that you factor out a negative will get switched. Okay, so this was negative 12n squared before. It's now positive, and this positive 108, guess what? This positive becomes a minus. Okay, so let me just write down what we just did. So when we factor by grouping, the first group will be n to the fourth minus 9n squared plus 4n to the third minus 36n minus 12n squared minus 108. Alright, what we're going to do next is we're going to proceed to extract the greatest common factor from each group. Okay, so from the first group, the GCF, we have 1. So 1 here for n to the fourth and 9, the GCF is 1. For n to the fourth and n squared, you could just simply factor out the variable term with the smaller degree. Okay, so we have n to the fourth and n squared. The GCF is going to be n to the second power because n squared goes into both evenly. Alright, so n squared goes into n to the fourth n squared times. How did that happen? When you're dividing exponents with the same base, you subtract. Okay, so we basically subtracted 2 from 4. That's why I have n squared here. And then when we factor out n squared from 9n squared, these two divide out evenly, so we're left with 9. So basically, if we carry out the division process or the factorization process, this power comes down to 2, and then this is divided out completely. And then that's how you have n squared minus n. Alrighty, so that's the first group. Let's go to the next group. Same process, factor out the GCF. 4 and 36. 4 goes into 4 once and into 36 9 times. So we're going to have 1. Okay, let me fix this. We also can pull out a variable term, so we can also pull out, we have n to the third and n to the first power. So guess what? We pull out the smaller of the two, just pull out n to the first power. And then if you take out 4n to the first from 4n to the third, the 4's divide out, and you're left with n. And then if you take out n to the first from n to the third power, you subtract, and you're left with square. Okay? When I take out 4n square, 4n to the first, so just 4n from 36n. 4 goes into 36 9 times, and n to the first divided by n is just 1. Okay? So that's what you get when you carry out the division, the factorization process. And then over here, what goes? Well, we can just factor out 12, and then we're left with n squared minus, if you factor out 12 from 108, you get 9. Bam. So one way to check to see if the route we chose is correct is to examine the quantities in the parentheses. Okay? If the quantities in the parentheses are identical, then it shows that the grouping route that we selected is correct. If we did it the other way, where we have two groups with 3 terms in it, you will not have identical quantities in the parentheses. Alright, so this is an excellent approach because everything looks great right now. So the fact that we have identical quantities, that gives us the opportunity to move on to the next step, which is to factor out these identical quantities. Alright, so what we're going to do is we're going to factor out n squared minus 9 from all the 3 terms that we have here. So we factor it out, we have n squared right here, n squared minus 9. Now, ladies and gentlemen, when you factor out as indicated up here, it is as though you're dividing by that factor. Okay, when you're factoring out, you're dividing. So when you divide, when you factor out n squared minus 9 from all these terms, it's as though you're dividing n squared minus 9 through them. So what impact will that have? It basically means that this will become like 1, because n squared minus 9 divided by n squared minus 9 is 1. This is 1, and this is 1. So what you're going to have left is the terms, the GCFs that you factored out earlier. Okay, because you already factored out this common quantity in all 3 terms. Now what are we going to do next? What we're going to do next is simply group these terms that are left together in their nice little parentheses. So we have n squared plus 4n minus 12. Okay? Alright, so let's proceed with our factorization process. We can factor out n squared minus 9. Do you recollect what format this is? This binomial right here is a difference of squares. Alright, and there's a special formula that can be used to facilitate the factorization of difference of squares. Okay, so recall the following concerning difference of squares. If you have a difference of squares, a squared minus b squared, this can easily be factored into a plus b times a minus b. Okay, all you do is you take the square root of the first and last terms, and then you express the roots as sums and differences. Same thing we're going to do here. Okay, this is a squared minus b squared, so we can just root this and root that and express the roots as a sum and a difference. So the factorization of n squared minus 9 is n plus, so the square root of n squared is n, the square root of 9 is 3. Okay, n plus 3 times n minus 3. Bam. So we have that factored out. Now n squared plus 4n minus 12. This is a quadratic trinomial. Let's go ahead and factor this. If you look at the options that we have right here, we can clearly see that it is factorable. Okay, so just based on what we have so far, can we carry out some eliminations? Absolutely. N squared minus 9 is not completely factored, so this cannot be an answer because the question asks for a complete factorization. Option 3, n minus 3, n minus 3 doesn't match what we have here, so we eliminate that also. The answer is either option 2 or 4, depending on what the factorization of this quadratic trinomial is. Alright, so we're going to shift to the side here, and what we're going to proceed to do is we're going to proceed to factor this quadratic trinomial, n squared plus 4n minus 12. We're going to use the x game, okay? So let's go ahead and do that. So if we want to use the x game, we have the x game, or we can also call it the magic square or the AC method. Doesn't matter what you call it, same procedure. So set it up. We have AC is negative 12 and B is 4. Okay? So now we're going to play the game. What two numbers multiply to give you AC and add to give you B? Alright, so as you can see, this is A right here, this is B, B is 4, and C is negative 12. Okay, that's why AC is negative 12 and B is 4. Alright, so what two numbers multiply to give you negative 12 and add to give you 4? That's how you play the game. Now let's write down all the pair of integers, pair of integers that multiply to give you 12. Okay, so 1 times 12 gives us 12, 2 times 6 gives us 12, 3 times 4 gives us 12. We have a complete loop. Alright, so which combination do you think we can use here? The first one gives us 11 or 13, the second one gives us 8 or 4. Voila, that's the one that we want. We want this one right here, okay, because this is the one that can give us the number on the bottom. So we're going to put in 2 and 4, and then 2 and 6, and then work with the signs. So what sign combination can give us a negative product and a positive sum? Since the sum, the combination is positive, that automatically tells us that the bigger number must be positive. So this is going to be negative right here. Okay? So we have our x game completed. Now since A is 1 in this problem, there is no need for grouping. Okay? So since A is equal to 1, you can just skip the grouping process. So skip grouping. What does that mean? It means that we can jump from this x game to the factored state. So I'll just use is negative 2 and 6, and the factored form for this quadratic trinomial is going to be n minus 2 times n plus 6. Like that. Okay, so that's the factored form. So we can write it like this: n minus 2 times n plus 6. We know that multiplication commutes, so it doesn't really matter the order that we write it. We can also write it as n plus 6 times n minus 2, just to make it consistent with the options that we have here. So we insert that back into the problem, and our final answer, the completely factored form, will be n plus 3 times n minus 2, times n minus 3 times n plus 6 times n minus 2. Ladies and gentlemen, that is a completely factored form of the given quartic with 6 terms. Okay, so this is basically how you use multiple factorization methods, namely grouping, difference of squares, and a x game to factor higher degree polynomials. Alright, we'd like to know your opinion. Which factorization method do you find easiest? Factoring by grouping, the difference of square factorization method, or the x game? Okay, let us know which method you prefer in the comment section below, and tell us why do you feel that that method is the easiest method when it comes to factorization. Alright, Let's take a look at question 12. In question 12, we're being assessed on how to solve quadratic equations algebraically. Alrighty. Question 12 reads, what is the solution when the equation wx squared plus w equals 0 is solved for x, where w is a positive integer? Alright, so let's go ahead and solve this. So we have wx squared plus w equals 0. Alright, so w is a positive integer, so you can put any number that you want in there to solve the problem if that makes you happy, but it doesn't really make a difference. So I'm just going to solve it with w, just assume it's a number, okay? So what we're going to do first here is we're going to factor out the greatest common factor. And the greatest common factor in this case is w, so you factor out w from both terms, and you're left with x squared plus 1 equals 0. Now, since w is a positive integer, I have the freedom to divide both sides by that, okay? So divide both sides of the equation by w, and then so I'm basically dividing this whole thing. So when you divide by w, that's gone, and then 0 divided by any positive integer is 0. So we have x squared plus 1 equals 0. Okay, so 2 more steps to finish this problem off. We'll get rid of 1 and then get rid of the square by taking square root. Alright, so let's do it. So first step, subtract 1 from both sides, and then you have x squared equals negative 1. And then you take the square root of both sides, square root, and then remember whenever you take the square root of a square, you always end up with absolute value of x equals, what is the square root of negative 1? Square root of negative 1 is I by definition. Okay, so don't forget, square root of negative 1 is I. Okay, so now how do we get rid of this absolute value bars? Just replace it with plus or minus. Plus or minus x is equal to I. And then you can divide both sides by plus or minus 1. And then your final answer is going to be, so let's do that. Divide both sides by, just to get rid of this sign, by plus or minus 1. And your final answer is going to be x equals plus or minus I. Alright, so this is the solution to this quadratic equation, wx squared plus w equals 0, where w is a positive integer. The answer to question number 12 is option number 4. Alright, so question for you. Is there another way that you think we can solve this quadratic equation other than the approach I used here, namely isolating x squared and rooting it? If you think of a different method, maybe a method that's faster, go ahead and let us know what you think in the comment section below, okay? Alright, let's take a look at question 13. In question 13, we are going to be assessed on how to use the normal distribution curves, the mean, and standard deviation to determine what interval a particular percentage of a population falls in. Okay? Question 13 reads, a group of students was trying to determine the population of candies in a bag that are blue. The company claims that 24% of candies in bags are blue. A simulation was run 100 times with a sample size of 50 based on the premise that 24% of candies are blue. The approximately normal results of the simulation are shown in the dot plot below. So we have the graph right here, the dot plot of the simulation. The simulation results in a mean of 0.254 and a standard deviation of 0.06. Question. Based on this simulation, what is a plausible interval containing the middle 95% of the data? Okay. Alright, so in this question, we just need to remember what the interval, the different percentages of the population falls into. When you're dealing with normal distribution, you just need to know what interval the 68% of the population falls in. 95%, and 99%. All right. So let's just refresh our memory on that real quick, and then we will go ahead and use that to solve the problem. So I'm going to show you a graphical representation of the percentages, percent intervals relative to the mean, and then I'll show you the representation algebraically. Then we'll use the algebraic representation to solve the problem. All right. So let's go ahead and draw a normal distribution curve. It's just going to be a rough sketch, nothing too special here. So if we have our normal distribution curve, so it looks something like this. Alright, so let's say we have a normal distribution curve like this. It's just a rough sketch. And then right in the center is your mean. Okay, so there goes your mean right there. And then, like I said, the three percentages we want to know are 68%, 95, and 99%. Now, if you go one standard deviation to the left, so that's minus minus sigma, and so let's say this is minus sigma right here, and then you go one standard deviation to the right, so that's positive sigma. Now this captures a certain percentage of the population. Okay, so let's go ahead and indicate what that is. So I'm going to make this red. So this particular percentage right here covers it covers about 68% of the population. Okay, so this covers 68% of the population. That's one standard deviation to the right or left of to the right and left of the mean. All right, so this represents about 68% of the population. So basically, in this region right here will be 68% of the population. All right. Now let's go further. What if you go two standard deviations to the right and left? If you go two standard deviations to the left of the mean, so 2 sigma to the left of the mean, and 2 standard deviations to the right, 2 sigma, we're going to capture, guess what? We're going to capture 95% of the population. Okay, does that look familiar? Well, yeah, that's what we're asked to solve here. Okay, we're asked to figure out the interval for 95%. So this is what we are going to be using. So 2 standard deviations to the left and right of the mean is going to be 95%. Okay, so from this is going to be 95%, 2 standard deviations to the left and right of the mean. And then if you go 3 standard deviations to the left and right of the mean, you're going to have 99%. That's for 3 standard deviations. All right, so let's go ahead and write it down. I didn't put 99%, the 3 standard deviations. I'm just going to write it down. Okay, so let's go ahead and write down what we have. So 68% falls of the population falls in within 1 standard deviation to the left and right of the mean. So mu plus or minus 1 sigma, or just plus or minus sigma. Okay, and then 95% is your mean, mu plus or minus 2 standard deviations, and then 99% is mu plus or minus 3 standard deviations from the mean. Okay, in this particular problem, we're looking at 95%. So we're going to be focusing our attention on this particular portion right here. So we're looking at this area. Okay, so that's basically 95% of the population, because you're within 2 standard deviations from the mean to the left and right. Okay, so let's go ahead and specify what we have, and go ahead and solve for the interval. So don't forget, our mean is mu, and in this problem is 0.254, and our standard deviation, which is lowercase sigma, is 0.06. All right, so the interval that we're looking for is going to be the mean minus the standard deviation. That will be the take you to the lower bound, and the mean plus the standard deviation. I'm using this equation right here, but I just broke it down. Okay. All right. So let's go ahead and put the numbers in there. So for the lower bound of the interval, we're going to look at the mean 0.254. Actually, we're looking at two standard deviations. I put one. So let's fix that real quick. So minus two standard deviations plus two standard deviations. What I just wrote is for 68%. We are looking for 95%. So two standard deviations, mu plus two standard deviations. Perfect. Okay, so 0.254 minus 2 times 0.06. That's for the lower bound. And then for the upper bound of the interval is going to be 0.254 plus 2 standard deviations, which is 2 times 0.06. Bam, like that. Okay, so these are just arithmetic computations. Let's fire up our calculators and determine what the intervals that we're looking for is going to be. So 0.254 minus 2 times the standard deviation, 0.06. Okay, 0.06. My calculator isn't cooperating this morning, so 0.254 minus that gives us 0.134. So that's the lower bound, and then the upper bound is going to be, I'm just going to recall what I entered earlier and change the sign to a plus to save time. And then the upper bound is 0.374. Okay, so that's the interval that we're looking at. So it's going to be 0.134 all the way to 0.374. Alright, so graphically, what's the significance of what we just did? Well, what we just did just shows that this lower bound here that we have, this value, is 0.134 for this particular problem, and the upper bound value right here is 0.374. The correct answer to question number 13 is option number 2. Alright, let's take a look at question 14. In question 14, we are being assessed on how to read solutions to an equation of functions when the representation is in a tabular format. Okay, question 14 reads, select the values for the functions f and g are shown in the tables below. So we have the graphs, the tables right here. And then the question says, a solution to the equation f of x equals g of x is. So how do we know what the solution to the intersection of two functions is? If the functions are presented in a tabular format. Graphically is the intersection, right? So how about numerically? How do you know that? So let's go ahead and write down what we're looking for. So you just want to note the following concerning the solution to this equation. A solution, there could be more, to the equation f of x equals g of x, basically two functions intersecting. This occurs at the x value where f of x is equal to g of x. Okay, So you have to be really careful here. We're not looking for identical x values. No, 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 that's not what we're looking for. We're looking for identical y values, identical output values. That will guarantee. So we're looking for the x value where the uh, y values are identical. Okay? So if you take a look at this, our focus is on the outputs of the two functions. We're comparing the outputs and we're trying to see where is f of x equal to g of x. That's what the question asks. It's not asking for where x is equal to x because x is the same thing, right? It will be redundant to do that. Alright, so let's look at this. Negative 4.8, no. Negative 6 is not here. Negative 4.7 is not here. Oh, we have 2.53. Alright, so we have 2.53 and 2.53. Bam, we have a match. Okay, let's keep on going. 3.01. Oh, wait, we also have 3.01. So which of these two is the answer? Okay, so the answer is going to be one of them. All right. So remember, we're looking for the x value, one specific x value, not multiple x values. One specific x value where the functions have the same output. Okay? So now we're going to look at the x's to see which scenario do we have just one specific x value on both cases. Okay? So we're just looking at one x value. So if you look at the first set, we have 8.52 and 8.52. Bam, bam. And then the next one, this is 9.01 and this is 13.11. That's a fail. Okay? So we're looking for one specific x value. These two y values are the same, but they're at different x values. We're looking for one specific x value. So that's not the answer that we're looking for. The correct answer is 8.52 because that is the specific x value where the outputs have exactly the same value. Alright, it's just like a point. Okay, so basically what we're saying is if you have two functions, let's say f, this is f right here, and this is g right here. Okay, so this point of intersection right here is the solution. The x value is 8.52 and the y value is 2.53. So we're looking for the x value that satisfies the point where the two graphs intersect with one another. Alright, so the answer to question number 14 is option number 4. Alright, so let's write that down. X equals 8.52 is the, remember, x value where f of x is equal to g of x. They're basically equal to 2.53. That's the output, that's the input value that results in this output. So the answer is option number 4. Alright, let's take a look at question number 15. In question 15, we're going to look at how to multiply complex numbers. Okay? Alright. We have this situation right here. The expression 6 minus 3x minus 2i squared is equivalent to. So in order to simplify this expression, we will have to multiply complex numbers. Okay, so 6 minus the quantity 3x minus 2i squared. So what we're going to do, since this quantity is being squared, we're going to write this as 6 minus 2 copies of this quantity multiplied by each other. That's what squaring a quantity is. And then we're just going to distribute here. Alrighty. So let's do that. We're multiplying two binomials, so we can just FOIL it out. First, outer, inner, and then last. Watch out for this minus in front of this parenthesis, okay? That basically tells you to proceed with caution. Alright, so we have 6 minus 3x times 3x. 3x times 3x is 9x squared. 3x times 2I is negative 6xi. Negative 2 times negative 2I times 3x is negative 6xi again. And then negative 2I times negative 2I is positive 4I squared. Okay? Alright, let's combine like terms. We're going to have 6 minus 9x squared. The two middle terms are like terms, so if we combine them, we're going to have negative 12 xi plus 4I squared. Okay? Alright, so that leads us to the question, is this quantity in this parenthesis, 9x squared minus 12xi plus 4i squared, has it been simplified completely? That's the question. And the answer is no. So something you want to note is that powers of I greater than 1 can be simplified. Okay? So if you have any polynomial term with a I components that has a power of 2 or greater, that particular term can be simplified. Okay, so that leads us to the question: how do you simplify powers of I that are greater than 1? Okay, so remember how to simplify powers of I. Very important point to keep in mind. If you have I to the first power is I, it doesn't need simplification. I squared simplifies to negative 1. I to the third is a product of these two, negative I. I to the fourth is I squared times I squared, which is positive 1. Okay, and then the pattern just continues forever. So if you go I to the fifth is right here because you're just multiplying I times I to the fourth. So I to the fifth is I, and then I to the sixth is negative 1, and then this is I to the seventh, this is I to the eighth, and then it just wraps around modulo 4 as you go on. Okay, so basically this helps us to see that this I squared component should be reduced. Alright, so let's go ahead and do that. So we have 6 minus 9x squared minus 12xi plus 4. What is the simplified form of I squared? Bam, negative 1. Okay, so it's negative 1. Close that. Let's go ahead and simplify a little bit more. And then we can distribute the minus and combine like terms. Let's see what we got. We have 6 minus 9x squared minus 12xi minus 4. Distribute this minus to everything. We have 6 minus 9x squared plus 12xi. Distribute the minus to this minus 4 right here, plus 4. Okay? Are there like terms that can be combined? Let's see. Yes, we can combine positive 6 and positive 4. So that gives us negative 9x squared plus 12xi plus 10. Alright, so ladies and gentlemen, that is the equivalent form of the original expression that was provided to us. The answer to question number 15 is, let's see, negative 9x squared plus 12xi plus 10. Option number 1. So that's the answer right there, option 1. Okay, quick question for you. Using this simplification formula that we have right here, what if you had the following? Okay, what if you had I raised to the 100th power? What do you think the answer is? Go ahead and post your answer in the comment section below and specify to us exactly how you came up with your result. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents, do let us know by giving us a thumbs up, We'll greatly appreciate your positive feedback. Don't forget to subscribe to our channel for updates to the remainder of this review series and other great math tutorials to help you be successful. Um, if you have any questions, comments, or special requests for math tutorials, just post it in the comment section below and we'll try to respond to your request. Don't forget to visit our website at mathgotserved.com where you can gain access to the transcripts of this presentation and other great resources to help you master Algebra 2. Thanks again for watching and have a wonderful day. Goodbye.